Okay, I want you guys to go find example number 7. Go find example number 7 in your notes. In your notes. Okay, as you guys find example number 7 in your notes, for those of you that worked on homework last night, I heard someone got to like the 50s. Somebody got stuck on, I think it was somewhere in the 30s. There was a weird equation you had to take a derivative of for checking. Which one was that? 30 even? Okay. What was so weird? I don't want to just totally fly by it, and I've answered it, I think, 2 or 3 times, so why not just do it for everyone's benefit? Number 30 gives you the function 3x plus 2y squared equals c. And you're supposed to be testing it in the equation. I don't even remember this one. It's like y prime, but what else is there? Equals 0? Okay, it wasn't meant to be tricky, but why was it? Like, look at it, and why would, there are a lot of lights on. Why would it be tricky for some? Yeah. Don't we have to somehow find the y prime to plug in? Right? And why were people confused? Now, hold on. This is a last semester topic. They're probably confused because y by itself, but no big deal. We're bigger than that. What's it called when we take the derivatives, however it's taken? Implicit differentiation. It says just go. Okay, just go. What's the derivative of 3x squared? What's the derivative of 2y squared? 4y dy dx, but in this context, y prime would be the best way of writing it. Then 0. So can't I go ahead and solve? 6 over 4 is going to be 3 over 2, right? Couldn't I just go plug in that guy? Does that make sense? And then I think the 2y's end up canceling. The 3x minus 3x ends up equaling 0. Does it work? And the answer is, I believe so, yes. Yeah, you did have to keep going to solve for C. Okay.
Another way to check also be to pull out a 2 on the sequence and then on both sides so that this function 3x plus 2y times y prime equals 0.
Yeah, I was thinking of finding y prime and plugging in, but Sean's saying the other way is that you could have just kept going and pulled out. When you divide, it will match, and so you're like, oh, hey, yeah, it's the exact same thing. Do you guys solve, and do you agree, David, that C was 21? Well, remember, when they give you a point, you just plug in x, plug in y, right? And then solve for C? Yeah, just plug in x, plug in y, for C. C was 21. Were there any other places while I'm in the book looking at homework? I knew that one got tricky. 38. 38 was kind of fun. That's okay. Talk it out, Sean. Well, Nathan, first of all, what was 38's problem? You were supposed to be solving, I think, the differential equation. Okay.
And it was dy dx, and what I have is dy dx equal to ex over 4 plus e.
4 plus e to the x. Okay, first off, directions. It's important to know the directions. When it says solve for the solution of the differential equation or for the general solution, what's it talking about? This is the derivative. Solving the differential equation means go back to y. So aka integrate. But I can't integrate until I get the dx on the other side and now say, hey, my bookends are ready, right? And then bookends are ready. The only way to solve this guy is to think about u sub. So then u is equal to 4 plus e to the x. The nice thing is du is equal to e to the x dx. When you solve, dx is equal to. And some of you are getting better at this, so maybe some of this is getting to be kind of like mental math, which is good. Just be careful. Because I promise you there are u sub problems where they try to trick you in the sense of if you go too fast, you'll miss part of that u sub and their constants will be off. But the nice thing in this one is, yes, the e to the x does just simply cancel. You end up with the integral of 1 over u du, which does lead you to ln of 4 plus e to the x. Now, here's something crazy, plus c. Oh, the integral formula for 1 over u or 1 over x always leads us to ln of absolute value because here at the beginning, use, or the x's can be positive or negative. No big deal. Whatever. 1 over x goes both sides of the axis, the y-axis. As soon as you put an ln in, it restricts unless you put absolute value. So since this one said everybody's legal, I have to make sure with ln everybody's legal. That's what's going on. Guys, why though will the absolute values disappear when they simplify? E to the x will always be positive, and 4 plus e to the x will always be positive. So the absolute value bars are redundant, so it doesn't need to stay. It would be legal for it to be taken away. Does that kind of make sense? Dun, 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 dun. Anything else besides 38? 47. 47 gives you the differential equation, asks you to complete the table. Oh, yeah, just take your x, take your y for each point and plug in and just literally find the slope. And then if you look at the slope field, you should see those slopes shown in the sense of like a high positive will be really steep up, or a high negative will be really steep down, or something that's 0 will be horizontal. Does that make sense? So it's giving you the idea that if worse comes to worse, you don't know how to match, you can always plug in and then just kind of visualize the slopes and if they make sense. Anything else besides 47? Okay, 92. Is that the multiple choicey one? Oh, the free response. Letter A, hopefully you guys were like, oh, go find the point 0, 1, right? And then follow the flow. Didn't it look kind of parabolic, I think? Hold on, I need to get zoomed in. Go upish, downish, maybe back upish, yeah? Looks sinusoidal-ish. Oh, not on the left side. The left side just kind of drops. Yeah, there's not really an easy way. Hold on, let me follow the flow. Upish, downish, seemingly back upish. On the left, downish. Huh. I think you could have almost made it sinusoidal. I wouldn't totally mind if you just like a downwards parabola that's shifted over a little bit to the right. You could have made that go a little bit more up. You could have actually made it sinusoidal on both sides. There's a way. You would have had to make a really steep turn, though. That would have been pretty awkward. We could have made a really steep turn in between -1 and -2 and had a little minimum right there. Ew, that is gross. Letter B, though, says write an equation of the tangent line. Ooh, this one's a great question. Great question. Okay, what'd they give you in number 92 for your differential equation? Equals? Oh, makes so much more sense. Pi. Oh, got it. Pi is the x and y is the 1. Okay. And it's saying to use the tangent line, right? To approximate? What? Yeah, go straight to point slope form, right? So y minus y1 equals m times x minus x1. Come on, kids. What goes in the y1 spot? 1. What goes in the x1 spot? Yeah, this would need to be dy dx at pi 1. So I go back to the derivative because the slope of the tangent line is found from the derivative. And I have the derivative. I just need to plug this guy in and get the value. So this is going to end up equaling 4 minus 1 times cosine of pi. Hey, 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 unit circle. 3 cosine of pi. Good. Now the struggle is it says find the tangent line, check. If you got here, that'd definitely be worth points on an FRQ. But it says to use it. To do what? Plug it in. So y minus 1 is equal to negative 3, 3.2 minus pi, which means, ready? F of 3.2 is approximately 1 minus 3 times 3.2 minus pi. Why am I stopping? I don't need to simplify an FRQ ever, not when it comes to numbers. So the cool thing is all I had to do was get y by itself by adding the 1, and then I say, sweet, that's my approximation for this guy. The y on the tangent line would be the approximation for the function. Now, is it going to be a little bit off? Yeah, because when it skims, remember, it's going to diverge pretty quickly. But they said to approximate, so I did. Dun, 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 dun. Could you plug it into your calculator? Yeah, sure. Why not? Do you need to? No. All right, cool, kids. We covered some questions today. We'll check the evens tomorrow. I technically just have section 5.1, homework number 33, again due tomorrow because some of you got stuck and you need to keep pushing through that getting stuckness. Anyway, but our goal today is to get as many examples done in the notes handout. Why the notes handout? Because what are you supposed to be working on tonight? The worksheet. And guess what's in the worksheet? Well, hold on. First of all, the first page, just make me some slope fields. Make me some slope fields. Do you have to make tables of every single point? The answer is no. But find patterns and plug in a few points and then try to figure out the entire slope field. Have you had some practice in that in homework? A little bit, right? But this one, hopefully this page, by the end of this page, you're like, I know how to do a slope field if I need to. I know how to make it a +1 or a +2 or a +4 or a -1 or a 0. I know how to plug in points. But as soon as you turn the page, all of a sudden, what do you got? AP-ish stuff. Oh, sorry, Charlotte. Matching, and then soon and very soon, you have some FRQs too. So, notes. Ready? Example number 7. We're just going to bust through as much as possible. Let me make it big. Zoop, zoop. The very first thing you always have to ask yourself when matching is, what are you matching it with? What are you matching it with? Okay. Exactly. Why did Sean say slopes, though? Differential equation. So we're actually looking at the slopes, right? Differential equation, I'm looking at number values of the slopes. What if these had been y equals? Now, the wording would be the general solution of the differential equation. That's kind of what you were asking on that one question. So if it's y equals, they're general solutions, and general solutions are seen in a slope field by following the flow. Following the flow. Does that make sense? Okay. So we're thinking about the slopes themselves. Can anybody make a match? And tell me why. Is 4A. 4 is A. Pause. Hold on. Austin got one. This is the first one I heard. What'd you see, Austin?
I saw like horizontal tangent lines, and I saw the points for like 1, -1, or -1, and so a lot of those options.
Good. Now, he might not have thought that in his head, but he was like, oh, 1, -1, 2, -2, 3, -3. Which one subtracting? Oh. Or adding the opposite would cancel. Perfect. Does that kind of make sense, guys? I heard someone else I think had a match. What's another one? Two only has a y, and what does that hint? It will have to go with C. Because when y is equal to something like, I don't know, I'm just guessing, when y is equal to 2, whether it's 1, 2, or 2, 2, or 3, 2, or 4, 2, when y is equal to 2, won't all the slopes be the same? Yeah. So y equals are always horizontal lines. So for one y, for one horizontal line, all the slopes will be the same. B would have to be 1 because what do you see, Sean?
Because with the vertical lines, you have to recognize that that would be x.
For a vertical line, different y's, but all the same x, all the slopes remain the same. Yeah. And guys, in notes yesterday, didn't we, and maybe you didn't get it all written down, maybe you need to go back and look at it, but didn't we say something to the effect of, hey, when you only have y's, they follow horizontal lines? And when you only have x's, they follow vertical lines? So that hint is there for you guys to look at, yeah? So why does it make sense that number 3 must be D? I mean, it is the last guy, but who can give me a defense as to how that works? Okay, it is circular, but the problem is, do we know? It is reflective, that's true. Interesting. Hold on, I'm trying to think if that makes sense. X has to be above y versus y being above x. Technically, the reflective thing could happen in the y above x, but what's going to be different is all of these slopes, it's going to be basically like, they're going to be going like differently. Like instead of curling in on themselves, it's going to be like going the opposite way. Well, not necessarily, but let me point you to a different clue. Do you see my horizontal tangent lines? Horizontal tangent lines mean dy dx is 0. What line is this where all the derivatives are 0? When x equals 0. Plug in 0. Oh yeah, they'll all be 0. Pause. You can't see them, but can you see if this is a circle, which it is? What's going to be the tangent line here? No, it's going to be vertical. When y equals 0, you have d and e's. Oh. What's going to be different if it's flipped? Instead of the verticals here and the horizontals here, it's going to be the opposite. It's going to be the vertical here and the horizontal here. So it's going to be a little bit different if those were switched. So I still like looking at horizontal verticals. Sarah, your idea about the... Say instead of thinking about the reflective, think about the signs. In the first quadrant, aren't x's and y's both positive? Which one, if you were to plug in all positives, will get negative slopes? No, 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 yes. Positive over a positive times a negative, booyah. So the signs are a good idea to think about with quadrants. I'm just not really sure you really want to think about reflective. That's getting a little bit too deep. Not deep, but off base a little bit. Yeah. You could do the antiderivative of every single one, but this one's just matching. So we could. Charlotte's saying, why not antiderive? Guys, antiderivative of this one, if we move it over, wouldn't it be a parabola? Which one's parabolic when you follow the flow? This one, right? This one, if we we haven't done one of these. What would happen if we antiderived this guy? You would have to do dy over y equals 1/2 x dx. Isn't this going to be, ln of y equals 1/4 x squared plus, did this just get a lot harder? Because y is no longer by itself, and so then I'm going to have to, long story short, Charlotte, let's not stress about his antiderivative right now. We're going to talk about that type of antiderivative a lot, but just not right now. Could we antiderive number 3? We could. Wouldn't we move the y to that side? And the dx to this side? Then I'll get y squared. We could have a plus c here. We would end up with a plus c1 over here and a plus c2 over here. So we could just move the constant c. But then I'd have to solve for y. See how it's harder? Not impossible, but harder. Hold on. I said so far they're all possible, just these two are harder. What about this guy? I have to move my bookend, right? But as soon as I move my bookend, what's going on with that y? And I can't divide. If I divide the y, then I have a y stuck with this x. If I subtract, well, I can't subtract. It's times dx. This is one I said yesterday is impossible for us to integrate. Start looking at number 8 as Tyler asks a question.
For like 2, could you do dx over dy equals 1 over 0.5y, or is that very...
No. Because I need to have my differentials out of denominators bookended with an integral in order to integrate. Does that make sense? Yeah. Example number 8. Ooh. Solutions. When they say solutions, what are they talking about? dy's or y's? Y's, good. General solutions. We had to deal with that in that homework question. So solutions, they mean y's, aka follow the flow. So when x is less than 0, isn't that to the left of the axis? When x is less than 0, are the solutions decreasing? Yes and no, right? Depends on where you start. Solutions, this means flow. The y equals, back to the original. Follow the flow. Is the flow decreasing? Yeah. No. So for all x less than 0, yes, no, Because if I picked a point right here, the solutions would be increasing. If I picked a point here, the solutions would be decreasing. But this one says, wait a minute, I'm to the left also. So no. Number 2, all solutions level off near the x-axis. Wherever you choose a point, when you get near the x-axis, does it seem to be leveling off? Yeah, all solutions seem to be leveling off near the x-axis. For all y greater than 0, all solutions are increasing. Wait, y greater than 0, isn't that above? Increasing? Yes. So what's the good one? X less than 0, remember when x's are negative, you're to the left of the y-axis. Does that make sense? So x is negative 1, 2, 3, 4. So if x is less than 0, you're to the left. You're looking here. And they say everybody's decreasing? Well, all of the ones here are decreasing. But to the left, what about these guys? They're increasing. Well, you look at the x-axis, and you say, which of these x's are negative? Oh, all of these ones. Okay, so it's all the points that go with these ones. But yeah, you're right. You kind of think about the y as the divider. Does that make sense? Yeah. Ooh. Vertical. We already talked about this today. What does it take to have a vertical tangent line? Undefined, which means denominator has to equal 0. dy dx does not exist. It's not going to exist when 4x plus 2y equals 0. If you solve for y, subtract the 4x, divide by 2. Does that make sense? You guys, think through example 10. Ready, set, go. You can talk in your groups. That's totally fine. I don't mind you guys talking it out. Sometimes that helps. But I am not helping yet. I am not helping yet. When you look at a condition, let it point you to choosing a point and following the flow. When you look at a condition, let it lead you to choosing a point and following the flow. Oh, these are depressing things on the board. Okay, what have you guys figured out?
It's not 1.
It's not 1? Let's go see. Y of 0 means f of 0, right? When x is 0. So here's x is 0. If it's greater than 0, pick a point. Follow the flow. It doesn't approach 0 as x approaches infinity. Yeah. Nope, that should be infinity. Okay. 2, if y of 0 is in between 0 or 2. Does that make sense? Sorry, 0 and negative 2. That's in this little region right here. Follow the flow. I guess like that?
She's doing it. She's doing it.
And I guess like that? Oh, yeah, looks like negative. And I only know the negative 2 because, well, actually I can see. So if I pick a point here, it sure seems like the limit negative 2. Yeah, looks good. And if y of 0 is less than negative 2, well, sure looks like it, right? But you don't need to find the piecewise. You don't need to find the piecewise. Just automatically. Don't shut off, though. Wait. So I chose, I'm coming, Nathan, I'm coming, but y of 0 is less than negative 2, any of these points, and if you follow the flow, where's the limit going, though? Negative 2 again. Okay, Nathan, go ahead.
So why are you looking at the y values instead of the x values?
Y of 0 is the same thing as f of 0, which is the y value when x. Got it. You have to think about function notation. They wrote the y of is the same thing as f of, not y times. All right, now what are we up to? Whoo! FRQs. FRQs. Okay. Careful. Okay. I work with too many high schoolers. Anyway, struggle. All right. Kiddos. Today, have we already talked about, have we already in the past couple of days talked about how to sketch? Yes or no? Okay. Have we already talked about using a tangent line to approximate? Yeah, we did that today, right? Have we found particular solutions plugging in burrs? Yes. Okay. Have we compared? Well, over and under. Okay, it's a little bit nasty, right? I want us, in the time that we have, though, to find the equation that is the most different from things we have done. Does that make sense? Let's look at the next FRQ. That last part is a little funny. But I think that if that was a homework question or a worksheet question, we could just talk about that one part, right? Example number 12. Sketch. Okay, we know how to do that. Ooh. Letter B, concavity. Letter C, relative. Okay, let's do this one. Example 12. Are you ready? Okay. I'm not going to make a table, even though I probably should. We're going to work together and check each other's mental math. Yeah? At negative 1, 0. Is that going to be negative 3 halves?
Yes.
Okay. So negative 3 halves would be down 1, 2, 3 over 1, 2, something like that. At 0, 0, well, that's easy. That's just going to be negative 1, so down 1 over 1. At 1, 0, that's going to be negative 1 half, down 1 over 2. So what's happening to the slopes? They're getting less steep. Good. If I go to, what else do I have? Negative 1, 1. That'd be negative a half, so down 1 over 2. If I do 0, 1, 1 minus 1 is 0. Oh, there's a flat one. That's super important. The AP graders are going to be looking for negatives, but also that flat guy is super important. 1, 1. Well, the 1's cancel. Oh, it's positive 1 half, up 1 over 2. And if I do negative 1, 2, 2 minus 1 is 1. 1 minus a half is positive a half, so up 1 over 2. All of a sudden it's going this way. 0, 2. That's going to be up 1 over 1. And then 1, 2. That's going to be 1 and a half, or 3 halves. So 1, 2, 3 over 2. A little bit steeper. You guys agree mostly? Okay. Letter B, though, that's where it got interesting. How do I find the second derivative? Implicit, just go for it. Implicit, just go for it. If I take the derivative of the left-hand side, isn't that d squared y over dx squared? Okay, how do I take the derivative of the right-hand side? Go for it. What's the derivative of 1 half x? 1 half. What's the derivative of 1y? 1 dy dx, or 1y prime. What's the derivative of 1? 0. I'm not done. If you want to be super snazzy, I guess you could simplify that. Do you necessarily have to simplify that? No. Okay, there's a second derivative. Nice thing is he was already by himself, so when I solve for him, I'm done. Well, describe the region in the xy plane in which all solution curves are concave up. Do we have enough in this picture to try to figure out concavity? I don't think so. But what do we have? And when I have a concave up portion, doesn't that mean my second derivative is what? It's greater than 0. So can't I say, hey, I just found him. 1 half x plus y minus 1 half. What do they want? You don't have to describe it in words. Give them an equation and say, hey, here's the inequality. Technically, they didn't say y has to be by itself. So to be honest, I think you could probably leave it like that if you were unsure of whether you could do this well. But the safer way would probably be to get y by itself. All the solutions, or all the points above the line negative 1 half x plus 1 half, it's going to be concave up. You don't have to, when it says describe the region, you can give an inequality and say, hey, look, there's the region. That's where it's going to happen. Letter C says, ooh, what does letter C say? You guys see particular solution, right? Does it say I have to find? Do I have to integrate? No. Good, because didn't I tell you it's impossible to integrate when you have x times x plus y? Okay, I told you it's impossible. What do you think was one of the most common mistakes of all the AP kids this year? They have been trained so well that whenever you see particular solution, you're always integrating, that they all tried to integrate, and guess what? None of them could do. Struggle. They didn't say find it. They said let. Okay, whatever. We're talking about the original that I can't find. Okay, cool. They give me a point. Okay, cool. Does F have a relative min, a relative max, or neither?
He's got that one of them. Because let's follow the flow. Let's follow the flow. But that is the derivative. Oh no, that's the rate.
A little slow. And if we follow the flow, we have like a little basin, like a tub. It's awful hard to follow the flow.
Why is it even a possible relative extrema? Because the derivative is 0. Isn't that a critical number? And if the derivative is a critical number, shouldn't we be thinking about whether the derivative is changing signs right before and right after?
Yes, sir.
Hey. So we can already see the flow, but we could also plug in some more points and plug in like negative 0.1 and positive 0.1 if you want. But we already plugged in some points, and didn't we already figure out, well, the slope before is negative and after is positive? Can't I say dy dx changes from negative to positive at that point? There exists a relative min. Not only did I give the answer, but I gave the justification by basically stating my forever card. Dun, 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 dun. Got it. Go get those points. Does that make sense? Nice. Letter D. Oh, are you? Sorry. Yeah, I didn't give you a lot of space on these. I just gave you the questions. Find the values of the constants m and b for which your y equals mx plus b is a solution. Ooh. Ooh, this sure sounds like we're supposed to be integrating, but what did I just tell you? Can't. It's impossible. Not when it's x plus y. We do know the point from C. We know 0, 1. Question. If this is a solution, shouldn't I be able to take his derivative and maybe match it up with something? What would his derivative be? I know it should be that because it matches, but just look at him. Isn't it just m? Can't I set m equal to 1/2 x plus y minus? Can't I also find his second derivative? What would be this guy's second derivative? Well, there's his first derivative. What's the second derivative? 0. Because the derivative of y dy dx will be m plus 0, so just m, and the derivative of m will just be 0. And then I can set, wait, I know the second derivative. Set that equal to now, Sean just mentioned we do know 1 point. We do know 0, 1. So we could also technically say one more clue. We could also say, hey, from the original, I know when y is 1, x is 0. Oh, well, hold on, wait a minute. Wasn't that nice and easy? Plug in 0, 1, and what do you already know? B is equal to 1. But how are you going to find m? Yeah. So we plugged in the x, we plugged in the y, we got b. But now that we have b, we don't have any other point, so we can't plug in another point and get m. But what can we use? A system of equations. No, look! No, well, come on, you party poopers. What if I subtract? Look! Pause! Guys! 1/2 minus 1/2 cancels. Y minus y cancels. M minus 0 okay, we have to be creative at times. But negative 1 plus 1/2 is? Dun 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 dun. Okay, I just told you that a lot of kids got stuck on this FRQ, but my question is, would you get stuck at C? I hope not.
I'd get stuck.
Okay, right this second, maybe. When we get to the AP, hopefully not, right? Come on, that's the point, is for us to get better, to get stronger, and to avoid the pitfalls of others who have gone before us. Hey, that's a life lesson. Whoo, whoo, man. Okay. Kiddos. I do have 15 seconds. Let's use those well. Number 13 looks a lot like other ones that we've done. Number 14 looks a lot like the one we just did, something to do with the second derivative and concavity. Number 15 looks, weird. Number 16 looks great. Guys, work tonight, not on finishing the note packet. This was just, let's practice what we can. Finish up the book work if you need to. Work on that worksheet. Come tomorrow with questions. Bye, cool kids. See you later. Beginning of class might be a little bit of group work collaboration on the questions you have. If you come in with a blank packet, are they going to appreciate you? No. Bye, guys.
It's time.
It's time. Let's get that last one.